afternoon and good afternoon. Today is the fourth session on the Maths A level, and today what I intend to do with you is we're going to look at the 2018 WJC Maths past paper. Let me just slideshow. My name is Grant Mackenzie, and if there's anything you'd like to sort of cover, go back onto the Carl Montgomery website, and there is 8 potential videos that you could watch and you can work your way through for the different topics. So as I said, for this one, this is the Maths A level WJC 2018. I've taken out the questions which are not relevant for this sort of exam summer series, so that people are not then not wasting their time, but not going to go through it. And then if you obviously we'll start with question 4, which is why we're starting on question 4, because question 1, 2, and 3, I think it was successive transformations and modulus. Those questions are not going to be examined coming this summer. So question 4, another trig question. So we have 2 tan squared theta plus 2 tan theta minus sec squared. Theta equals 2. Hopefully you see that we're going to use the sec squared identity. I can't seem to ever remember it. So if we think of cos squared theta plus sine squared theta equals 1. If we divide everything by cos squared, we will end up with 1 plus tan squared equals sec squared theta. I always forget which way the sine is, so it's easier. I just remember from AS, cos squared plus sine squared is equal to 1, and then divide by the cos squared if I want sec and tan, or by sine if I want cosec and cotan. So instead of sec squared, I'm going to be putting in 1 plus tan squared. So we end up with, not doing that. I apologize, where are you? There you go, back up, sorry, I've zoomed in there. So we're going to be 2 tan squared theta plus 2 tan theta minus, and then put in brackets 1 plus tan theta equals 2. Expanding would give us 2 tan squared theta plus 2 tan theta minus 1 minus tan theta, and I'm going to bring the 2 over, so it's going to be minus 2. So 2 tan squared theta and then plus tan theta minus 3 is equal to 0. Again, we haven't been told whether we need to factorize it or whether we quadratic formula, complete the square, whatever you're most comfortable with. It's going to get you the values, but you need to make sure you've got a method there. So then that's going to be 2t. I represent t as tan squared, and I'm going to put a 3 and a 1, and then I'm going to put a t. Now we need to sort out the sign, so I want it to be positive. So this one is going to be positive, and this one is negative. That'll give me 3t minus 2t, which will give me the plus t in the middle, or plus tan. Then it's 2t plus 3 equal to 0. 2t equals minus 3. T equals minus 3 over 2. And t minus 1 equals 0. T is equal to 1. Okay. Quick check. We have to make sure whether or not the question is asked it for degrees or in radians. In this case, it is degrees. I would say then that we have tan theta equals minus 3 over 2. So theta is tan to the minus 1 of 3 over 2. And tan theta equals 1. So theta is tan to the minus 1 of 1. Theta equals, for the first one, is going to be minus 71.57, and for the other one is going to be 45 degrees. Now remember, we need to make sure that we're doing these in terms of between the limits of 0 and 360. So minus 71.57, that's outside the range, but that's going to help us to work out the remaining values. Quick sketch of a tan graph. Dotted line, so that's my 90. Dotted line, that's my minus 90. Then it goes to 180, 270, another dotted line there. Moving this, extend this on, 360. Comes down, goes, and remember now this graph is simply for you. So we have when it's equal to 1, cross in there, and then when it equals, again, different, say green, when it equals minus 3/2, which should be putting in there, it will be here. Got those values there that I need to work out. Should I put this in there? Right. So for the 45, the next one is just going to be 180 plus 45. So my 2 points here are 45 and 225. For the next one on the other side, theta is equal to 180 minus 71.57, which is equal to 108.43. And also it is going to be 360 minus 71.57, which is 288.43. Those would be my 4 values for the 5 marks, all within range. Obviously, excluding the minus 71.57, but the ones that I want are 45, 225, 108.43, 288.43. Moving on to the next question. Here we have an 8 marker. Notice the questions are probably a little bit shorter than what you've got in the, let's look if I've got another page in this now. They're a little bit shorter than the AS, but they're worth more marks. So instead of maybe like 20, you're looking at 15. Right, this is partial fractions, and then we're going to have to integrate. So the partial fractions, the beauty about this, they've already given us what it needs to look like. So I am going to go straight in and multiply everything by the denominator on the bottom left-hand side, which is x minus 1, x minus 4 all squared. Obviously, in the question, you get the question paper, and then you're writing in the question booklet. So you would have to have written that out, first of all. I would highly recommend that when you're doing the sort of exam techniques of this, is making sure that you read through each of the questions, and obviously, because you don't have to do them in order, you can say do the 5th one, and then the 10th one, and then so on, to make sure that you get your best sort of marks in this. So then we would have had 3x is, notice that equivalent sign, a, and then the x minus 1 goes, so it's x minus 4 all squared, plus b, x minus 1, x minus 4, and then plus c, x minus 1. How you would sort of go about doing this, I would do a mixture of substitution and comparing coefficients. So I would probably substitute, first of all, x equal to 1. So sub in x equal to 1. So I have 3. And in substituting x equal to 1, b is 0 and c is 0. So I'm just left with a, which is 1 minus 4, which is minus 3 squared. Minus 3 squared is 9a. So that a is equal to 3 over 9, which is 1/3. That would be the first one. Then I would sub in x equals 4, and in substituting in x equal to 4, that means a is going to be 0, b is going to be 0, and then I have an answer for c. So I'll have 12 equals 4, it's going to be 3c. So then c is 12 over 3, which is equal to 4. Then after that, now, as I said, you could quite easily, there's nothing wrong with substituting something else in. I prefer not to, because I think then if I don't substitute something in, then I'm going to be able to sort of do it easier by comparing the x squared coefficient. In doing so, we'll have There is no x squared on the left hand side, so we have 0 equals. The only way I can get x squared here is by expanding this, and it's going to be a x squared, and then plus b. We know the value of a is a third, so then we would sort of say 0 equals 1/3 plus b, so b equals -1/3. I put the line down so I can work it out. So this is b. So then in doing so, we would, well, we found a, b, and c. I would like to tidy it up so that we're saying that this is equivalent to 1/3x minus 1. It's not going to be plain. Plus the minus 1/3x minus 4. Then it is plus 4/x minus 4 all squared. That's better. Done. There's your 3 marks. Then it says evaluate that given your answer to 3 decimal places. Well, what we're evaluating, because we can't integrate 3x over x minus 1, x minus 4 all squared. This is the reason why partial fractions, we've used them, so we can split it into 3 separate fractions. That way we can integrate those separately. So I'm going to be integrating, I'm going to put the third outside, log, give it away. So I'm going to be integrating 1/x minus 1 dx minus 1/3 1/x minus 4 dx plus 4 1/x minus 4. Actually, no, I don't want it written like that. X minus 4 minus 2 dx. And yes, I do know, and I am aware that the limits are 7 and 5, but I'll sort them out after I've done these. Okay, so these first two are straightforward. They're going to be logs. So it is 1/3 ln x minus 1 minus 1/3 ln x minus 4. Now, we need to integrate x minus 4 to the power of minus 2. So if you think about how you integrate, you increase the power and you divide by the new power. So we've got the 4 there. So it's going to be, let's put a plus on it. 4 times, well, the new power is going to be minus 1. So we're dividing by that minus 1. Times then x minus 4 to the power of minus 1. We needed to sort of have a look inside the bracket, which is x minus 4. If we were to differentiate that, then that would go to, if we needed to differentiate it, would go to 1. So it's not affecting us. So then if we were to do 1/3 ln x minus 1 minus 1/3 ln x minus 4, and then that's going to be minus 4/x minus 4. Now the limits are between 7 and 5. You have to show and know how to do sort of use the limits, but you have to show how to sort of pick that method markup. Now the calculator is going to do all the work for us. So it's going to be 1/3 ln of 7 minus 1, so that's 6, minus 1/3 ln of 7 minus 4, which is 3, minus 4 over, and then 7 minus 4 is also 3. Take away. 1/3 ln of 5 minus 1, which is 4, minus 1/3 of ln of 5 minus 4, which is 1, minus 4 over, obviously the ln of 1 is going to, just to sort of confirm, ln of 1 is impossible, 0, so that's going to go, but it would have worked out. So if you stick that directly into the calculator, then you will get an answer of 2.436. Correct the 3 decimal places. And then we're done. Question 6. Here we have, write down the first 3 terms in the binomial expansion of 1 minus 4x to the power of minus a half in ascending powers of x. State the range of values of x for which the expression is valid by writing x equal to 1 over 13 in your expansion. Find the approximate value for root 13 in the form of a over b, where a and b are integers. Okay, so if just remind you of the binomial theorem, which is 1 plus n x plus n minus 1 x squared over 2 factorial, where n is either a negative, is going to have the n is the power, which is either negative or a fraction. In this case, we've got both. That's the binomial theorem. It is in the formula booklet. And also for the purposes, the binomial has to have 1 plus x to the power of n. And we also have the region of validity given for this is minus 1x to 1, which is important for answering the second part of the state the value range. Right, now we know all that information, then first thing we need to make sure is this value here, if I highlight it in blue, has to be a 1. If it isn't a 1, you're going to have to sort of force factorize it and take it outside, put power on it so that you can have a 1 there. Since this is a 1, we don't need to do any of that. We would then just do 1 minus 4x power of minus a half, and that is equal to 1 plus minus a half minus 4x plus minus a half minus 3 over 2, which is obviously minus a half minus 1, minus 4x all squared all over 2 factorial, which is just 2. 2 factorial is better like that. It asks for the first 3 terms. 1 is classed as the first term in ascending powers of x, which is what we've given there. If we tidy that up, as I say, you can stick that directly into the calculator and that will sort out in terms of the numbers. What you would need to do, this one is 1 minus a minus, which is a plus, and half of 4 is 2x. Here we got a minus, which is a plus, and minus 4 squared. So that would also be a plus. So we have another plus. In my head, I would sort of say this as 4 and 4, because it's 4 squared. One of those would cancel with each of those, and that would cancel one of those. So then I am left with 3 times 2, which is 6x squared. Done. As I say, you can directly put that into the calculator and it'll work it out for you. It's just this used to be a non-calculated question, so I'm just used to doing it that way. Then next, the validity. So the region of validity used to be up here for this sort of expression or in the expansion in the actual formula booklet. So what you would do is you replace the x with whatever the x is you put in. So it's going to be minus 1 minus 4x 1. We then need to divide by minus 4 because we want to get x on its own. So it is 1 over 4 x minus 1 over 4. So our region of where the expansion is valid is going to be, you can write it as a modulus x, or you can write it as the above one. It doesn't make any difference. And then finally, so I'm going to cut this section out here. So then finally, we are told by writing x equals 1 over 13 in your expansion, find an appropriate value for root 13. So we have 1 minus 4x power of minus a half, which is equal to 1 plus 2x plus 6x squared. And wherever you see an x, you're going to put e. So it's 4 times 1 over 13 plus a half is 1 plus 2 times 1/13 plus 6 times 1 over 13 squared. Again, The right hand side, you can easily substitute and put straight into the calculator. So that we would have, I'm going to write this as 13 over 13, which is 1, minus 4 over 13. That's the power of minus a half. And then on the right hand side, 1 plus 2 13ths plus 6 over 1 13 squared. That is going to give you, let's tidy up a little bit, and then you can stick in the calculator, 1 over 13 plus 6 over 169. This then becomes 13 take away 4, which is 9 13ths minus a half, and that would equal 201 over 169. Because of that minus there, I get a different color. Because of the minus, we're going to flip it, and we're also going to square root it. So that what we end up with is the square root of 13 over 9 equals 201 over 169, which is the same as the square root of 13 over 3 equals 201 over 169, or the square root of 13 equals 3 times 201, 169. The square root of 13 is equal to 603 over 169. So you have then given your root 13 there in terms of a over b, where a and b are both integers. The answer is done. Be careful with things that I've circled in blue here now. So that minus a half, you need to invert it. If you were to have put into your calculator 1 minus 4 over 13, you would have missed that. So you wouldn't have had it as 9 over 13, and then trying to square root it, it wouldn't have looked really that pleasant. So try and keep it as a fraction so that when you invert it and square root it, you can see 13 on the top, which gives me the root 13, the 9 on the bottom. So when you square root the 9, you've got the 3, and then you go from there. Okay, next question. Okay, so we're on the arithmetic. Find the 7 numbers which are in the arithmetic progression, such as the last term is 71 and the sum of all numbers is 329. So we have got U7, if I put the formulas here, so it's UN equals A plus N minus 1D, then Sn equals N over 2, 2A plus N minus 1D. UN is the sum as the term value, and Sn is the sum of those values. So we have been told that such as the last term, find 7 numbers, which is an arithmetic progression. So the 7th term is equal to 71, which is the same as if we use this one here. A, we don't know the first term, plus 6D, because obviously 7 minus 1D is equal to 71. And we're told that the sum of those numbers, so S7 is equal to 329. So again, it would be 7 over 2, 2A plus 6D. And then we go from there. There are various different ways. It's just simultaneous equations. You can expand it. You can move the 2 over to the other side. Doesn't make any difference. What I had noticed when I was doing this is the same as 7 over 2 a plus 6d. Well, the a plus 6d is equal to 71. So that I've got 329 equals 7 over 2 a plus 71. And then obviously rearranging this, move the 7 down and the 2 up. I get a plus 71 is equal to 94. And then a is equal to, that looks too much like a 9. And then that a is equal to 94 minus 71, which gives me an answer of 23. So I know now a, which is the first term, is equal to 23. And I would substitute that back into the top equation so that I would have a plus 6d equals 71, 23 plus 6d equals 71, 6d equals 71 minus 23. So d equals 48 over 6, which is equal to 8. So I have my first term, which is 23, and my common difference, which is 8. It tells me that it needs to find what the 7 numbers are. So then, still haven't answered the question, 23, and then you're adding on 8 every time. 31, 39, 47, 55, 63, and then finally my 71. So those are the 7 numbers. Question completed. I hope I've given myself, no, I'm giving myself another page. That should be enough to fit everything. Okay, so we have question 9. Explain why the sum to infinity of a geometric series with common ratio r only converges when the modulus of r, or r, is equal to between less than 1 but greater than minus 1. So basically when it is a fraction or a decimal less than between 1 and minus 1, not inclusive. To do that, we would first of all have to have a look at the Sn of a geometric, which is a 1 minus r to the n over 1 minus r. So if it is the sum to infinity, we're saying that n is going off the limit of n is going to infinity, which would mean that if r was greater than 1 or less than minus 1, then that would be a really large number. If you think about it, 2 to the power infinity would be massive. So that value would just all increase and go to infinity. But if r is equal to a number between minus 1 and 1, then r to the n will tend towards 0 because you're making it smaller every time. If you think of a half squared is a quarter, half to the power of 4 is 1/16, and so on and so forth. So it's making it smaller and smaller and smaller. So then Rn converges to 0. So this Rn converges to 0. And as it converges to 0, you would expand the top. So as S for n sum to infinity, that's going to be a over 1 minus r. So the Rn is gone, expand the brackets, we get that. So it's only if, however, that is true. If r is greater than 1, it goes, the whole thing just blows up and goes, tends towards infinity. If it is less than between 1 and minus 1, then the Rn goes to 0, and then you can expand it, and that's why the sum to infinity is there. Part B, geometric progression V has first term 2 and common ratio r. Okay, so if we say that V has a first term of 2, and then it's got a common ratio of r, and then it's going to be 2r squared, because with geometrics, then the common ratio you're multiplying throughout as you go along. Another progression, W, is formed by squaring each term in V, show that W is also a geometric progression. Okay, so if that's the case, then it's 2 squared, 2r squared, 2r squared. So this would give us 4r squared, and this is going to be 4. Well, if this is a geometric progression, then 4r, let's choose different color, then 4r squared over 4 should then equal 4r to the 4 over 4r squared. If it doesn't, then the common ratio is different. So simplifying the left hand side, I'm left with r squared. Simplifying the right hand side, I'm left with r squared. Therefore, must be true. And you can keep on going if you wanted to. Satisfied that that's enough to show that the common ratio is the same, which is r squared. So I can move on. Given that sum to infinity of W is 3 times the sum to infinity of V, find the value of R. So what it's saying is the sum to infinity of W, I'll put it in brackets, is equal to 3 times sum to infinity of V. So, well, if that's the case, then we just need to work out using the formula from above. The sum to infinity is A, the first term, which is going to be 4, over 1 minus, and this time it is R squared because that would be the common ratio for W. That is equal to 3 times, here we have the A, which is 2 over R. Now a case of simplifying things. So I would say that is 4 over 1 minus R squared equals 6 over 1 minus R. You can use 1 minus R squared is the difference between two squares, so that you have 1 minus R over 1 minus R and plus R equals 6 over 4. So I've just brought that up. Then that would cancel because it's on both sides, they cancel. And I would say that that is 4 over 6 equals 1 plus R. Moving R over. And then you would have 4 over 6 minus 1, which is 2/6, or 1/3. For that to work. And then the last part, did I not give myself another page? No. Got one of myself another page. So then we've got A here, B there, and then in this section here we'll put C. It shouldn't be too bad actually. At the beginning of each year, a man invests £5,000 in savings account, earning compound interest at a rate of 3% per annum. The interest is added at the end of each year. That's important. Okay, at the end of each year, find the total amount of his savings at the end of the 20th year, correct to the nearest pound. So every year he invests 5,000 into a savings account, and it gives you that sort of compound interest. So the first term, because it's the 20th year, find the total amount at the end of the 20th year. So the first term is not 5,000. The first term is 5,000 times 1.03, because it's at the end of the year, so it's the end of the 20th year. So in doing that, that would equal £5,150 for my first term. My common ratio R is 1.03, because I'm adding that 3% on. It's the whole amount, which is 100%, and added the 3% on, so that's why it's 1.03. So my sum of 20 is equal to A, 1 minus R to the N over 1 minus R. So that would be 5,150, 1 minus 1.03 to the power of 20 over 1 minus 1.03. I'm putting that in your calculator. It wants it to the nearest pound. So it is 138,382. So £138,382 to the nearest pound. I didn't even know this one. Moving on to question 10. Here we go, parametrics. So we have looked at these again. It was one of the sort of questions, not this question particularly, but one of the things we've gone through. 7, 8, 9, yeah, you got 14 marks. So considering the papers are 120, you're looking at almost 14 marks is well over sort of 10% on this sort of question. There are two types of ways they can give you the parametrics in terms of trig, or if not in terms of trig, in terms of another sort of linear function t. So I've got plenty of room to this one. So if we look at part A first of all. So part A says x equals cos 2 theta, y equals cos theta. Find the Cartesian equation, which we need to for solving this. I just move my paper over. So you know cos 2 theta is equal to cos squared theta minus sine squared theta, or cos 2 theta. And now we've got our cos 2 theta here in terms of x, and our y is in terms of cos. So then I would say that this is 2 cos squared theta minus 1. Substituting in, I'm going to have to square this. So y squared equals cos squared theta, so that I have x equals 2y squared minus 1. And then you go for my 2 marks. Then says, show that the line x minus y plus 1 equals 0 meets C. Well, this is my curve C now. At the point where P is equal, at the point P where theta is pi by 3, and at the point Q where theta is pi by 2. So what we've got here is simultaneous equations. If I rearrange this, we have y equals x plus 1. If I substitute that into my curve, x equals 2 times x plus 1 all squared minus 1. X equals 2x squared plus 2x plus 1 minus 1. And expanding all of that here. This is part A, this is part B. If I expand all that, I have x equals 2x squared plus 4x plus 2 minus 1, which is 2x squared plus 3x, bringing the x over, that's going to be a minus, plus 1 equal to 0. And we would factorize, get that 2x and x and 1 and positive. So that gives me my 2x squared, gives me a 1, and then that's 2x and x, which is 3x with the middle term. So 2x plus 1 is equal to 0. 2x equals minus 1. X equals minus a half. X plus 1 is equal to 0. X equals minus 1. So I know my x coordinates. Notice as well that theta is in radians, so you're going to have to make sure you calculate this in radians. So if I was to then do x equals cos 2 theta, so cos 2 theta equals minus 1. 2 theta is cos the minus 1 of minus 1, which is equal to pi. So 2 theta equals pi, theta equals pi by 2. And then on this side, we would do the same. Cos 2 theta equals minus a half. 2 theta is cos the minus 1 of minus a half. 2 theta is, I believe it's 2 pi by 3. Theta is pi by 3 is required. I'd like to, so theta is pi by 2, and when theta is pi by 2, the coordinates are minus 1. If I substitute minus 1 into this, choose different color. If I substituted it into here, then I would have minus 1 in there, so y is equal to 0. And then for the other one, then you have x, which is minus a half. And obviously put minus a half plus 1, it's going to give you a half. So for pi by 2, I got minus 1, 0, which would be the x and y coordinates. For pi by 3, I'd have minus a half and a half. Write down the coordinates of P and Q. So this one is P, and this one is Q. 5 marks. Now then, determine the equation of the tangents to C at P and Q. Write down the coordinates of the point of intersection of the two tangents. Well, to do that, I need a gradient. So I can work out the y-axis mx plus c because they are told to be straight lines, because they're tangents. So I need to work out the gradient. I've already got the coordinates. So let's then work out the gradient. We need to do, we have x equals cos 2 theta, y equals cos theta. To work out the gradient, we're going to use dy by dx, which is dy by d theta, x by d theta. So dy by d theta, cos theta just goes to minus sine theta. And then dx by d theta, cos 2 theta would go to 2 minus 2 sine 2 theta. So that dy by dx is equal to minus sine theta over minus 2 sine 2 theta, which is sine theta over 2 sine theta. Perfect. So what would we then go from there? Well, we need points P and Q. If we were to put, let's have a look, which one do I want? If we were to put point Q in, pi by 2. So Q, we have theta equals pi by 2, and the coordinates are minus 1, 0. You put theta into there, dy by dx equals, well, it doesn't equal anything because sine of 2 theta on the bottom means that you're going to be divided by 0. So it's an undefined gradient. So that means that it's just going to be x equals minus 1 is the equation of the tangent. Because the tangent exists, it's just that the gradient is going to be undefined, so it's going to be like 0, or it's going to be sort of straight up. So as x equal, it's going to be straight up, x equal to minus 1. So that'll be for point Q. For point P, which is theta equals pi by 3, and I believe it is minus a half, half. We would work out the gradient, so dy by dx equals sine pi by 3 over 2 sine 2 pi by 3. And that actually, put in the calculator, gives a half. So then using y equals mx plus c, y is a half. The gradient is a half. The x value is minus a half, and then you've obviously got plus c. So that's going to be minus a quarter. So c equals a half plus a quarter, which is 3 over 4. So we have y equals half x plus 3 over 4. I don't think we've answered the question. We have worked out the lines. For Q, it is x equals minus 1. For P, it is y equals a half x plus 3 quarters. And then there was something else I wanted to do. Yeah, and determine the points of intersection. So in determining the points of intersection, just put x equal into there for minus 1. So y equals minus a half plus 3 over 4. So it is equal to a quarter. Point of interception is going to be minus 1 a quarter. And there you're done. That is, was that 40 marks we said? Okay, I think I have run out of time sort of to do question 12, but what I will do is I will write out question 12 like I've done with the other ones, and then I'll put it on the website under resources. Thank you very much for joining me today. I hope the last 4 sessions have been very useful. As I said, if you want to look if there's anything else that you want to sort of cover, then you can, there are sort of 8 sessions now, or 8 videos on the Callum Cymru website.